for yet something even more completely different.
Okay, I am.
David Chase.
So when I was asked to come to this conference, I really didn't have any idea quite what to talk about. And I didn't want to say something that I knew everyone would agree with. And it occurred to me that I could talk about unsafe extensions. This is a partial history. I foolishly left C# off the bottom, so we'll start at the top. Years ago, a friend of mine spent the summer at Xerox Park. I flew out to visit him and spent a day desk checking his cedar as he was madly preparing to leave, and was telling me all about this cool way that they had pretty much built the system bottom to top in cedar. Came pretty much all the way down to the microcode, and it was all safe and garbage collected and wonderful. And the stuff that you couldn't figure out how to do safe and garbage collected and wonderful, they had unsafe extensions. So how wonderful. And then I ended up working at Olivetti Research, first with Module 2 Plus and then with Module 3. And again, safe, garbage collected, wonderful. And at the bottom they had unsafe extensions to let you do the tricky stuff. And I went off to Sun Microsystems and several other places. And I noticed that some people at the University of Washington had gone and written an operating system in Module 3. And they'd use the unsafe extensions. And they said, but you know what? They're not quite right. There are some things that we want to write in safe code. And so they tweaked them a little bit. And then along came Java. And along came Natural Bridge, which is where I worked for 5 years. I was with Roger Hoover and Ken Zadek, and we were trying to figure out how to implement this thing. And in contrast to what Hans talked about, the benefits of nonconformity or the costs of nonconformity, we were pretty much whole hog going to be nonconforming. We knew from the beginning that we were going to be a compacting garbage collector. We didn't trust the OS to supply us with threads, so we knew we had to do our own thread system. And so we knew that whatever our runtime was, it was not going to look very much like what C expected. And so we knew that we were going to have add unsafe extensions. And I'm about to say that I think, and years went by and I saw IBM's and Suns, and I thought that theirs were really a mistake. But if the design decision in Natural Bridge had been left up to me, I would have made the same mistake. So some of what I'm doing here is channeling history, and some of this is telling you the good design decisions of 2 of my colleagues, and some of this is telling you my positive experiences working with a better selection of unsafe extensions. I also ended up talking about this with Jan Willem Maassen. I think some of you have worked with him at IBM. He had some experience with IBM's unsafe extensions. And then late in the game, Sun also added unsafe extensions. And then after I got to Sun again, about a year ago, I ended up talking with a guy named Dan Nussbaum, who had been at Curl, and lo and behold, they had added unsafe extensions there too. And now C# has them as well. There are some assumptions that I think I need to make, and these are probably not too controversial. Unsafe and safe doesn't make sense unless you have safe VM. I've always regarded all of these virtual machines as really being just another language. The bytecodes that come in, it's a really weird language, but it's a language. But what that means is that you can draw on your experience in a human-oriented programming language and map it to a machine-oriented programming language. Things like lexical scope in a language like Modula or Java correspond to single entry, single exit, or single entry and its property is undone on all the exits from the region, much like synchronized blocks, which your verifier is allowed to check, though most of them don't. I'm also assuming that safe code performance is pretty good. And I also assume that we cannot completely get away from native code. There will always be something that you didn't think about when you were designing your unsafe extensions, or something that's too weird, or something that's too much trouble to translate, or there might be an operating system underneath there. That happens. And there's also not a completely strict division between the compiler and the runtime, one thing that you want if you have unsafe extensions is good inlining. And I will gripe about Microsoft when I get to that. And this last one is sort of a preference of mine. I believe, especially when doing unsafe programming, that when I say something, I want it to be clear that I said something, and I want it to be clear what I meant. I don't like puns in that situation. I don't like things that accidentally work. I don't like things that work because the implementer did it the right way once. And I want to say what I mean, and I want everyone to understand it. So the why. It's mostly about native code. You want to avoid native code just because it has a cost to get to it. You want to have a smoother interface to the native code when you do need to call it. You don't want to call J and I just to loophole an int to a float. That's just crazy. You don't do that in practice, but you really don't, you shouldn't even write it that way in the first place. Because you have unsafe code, and unsafe code is more than just peek and poke, you can move around your native boundary, and you can put it, in some sense, when you do have a native call, you can put the boundary where it really ought to be, as opposed to, I had to put it somewhere else for performance reasons because I didn't want to cross it too much. By making it cheaper, maybe you can cross it more. By having the right way to talk to it, you can talk to the right native boundary, say the OS call rather than some library. And this also lets you do sort of a better engineering of the native boundary. Essentially, you might have two. You have one that really is for J and I, and you have another one that really is for your unsafe implementation stuff. And each of them has its purpose, and each of them is engineered to its single purpose instead of getting sort of a mishmash. If you take things and partition it off, and if you are explicit, you have fewer constraints on your safe code implementation. So just for example, the idea that you would have an atomic section for updates to two fields in the same object from the vexed. You really might not want to be forced to put those two fields in adjacent words of memory just because the programmer happened to write it that way. But if you must support the pun that says that your class layout just happens to look like the native class layout, you can't do that. I hate puns. It's good to have fewer constraints. I know in Bullet Train, and I'm sure in other VMs, the first thing you do is you take, for each class that comes along, each subclass, you sort all the pointers to the beginning of the object. So you can say, they start here, there's 3 of them. And then there's the next subclass. Starting here, there's 4 of them. They're looped together. You get a little bit better locality. You get a little bit more compact data structures. It's sort of what you want to do. And it's also faster if you have inline, because you don't have a native boundary. And it doesn't matter how fast your native boundary is, it's not inlining. And you can inline. There's some reasons why not. And I'm channeling some other people here, and some of these I agree with very much. When you write the unsafe code, you can write unportable code, and that's a bad thing. And in the whole bit about, well, be a good boy, don't write unportable code, it's just a bad place to be. You should recognize it as sort of a necessary evil. Your choice, when you make your unsafe design, when you design your unsafe extension, the choices that you make tends to reveal what you thought was an important place for your implementation to differ from the native platform. So, for instance, in Bullet Train, we were heavily into threading, and so there's a lot of threading-related stuff in our unsafe extensions. And we were, at the time, only on Pentium, and so we didn't really care that much. Small-scale multiprocessors, we didn't really care about all that memory barrier hoo-ha, because they got it right, and it was slow, and they didn't. When I say right, I mean they didn't have a choice. It's locked CAS or nothing. So you don't have a memory barrier operation because you can't say it. The last 3, or the last 4, you would really like to have a better type system, but we don't. And if we had a better type system, less code would be unsafe. Maybe no code would be unsafe. You would just prove that you've done it right, and then anyone could do it, but they might have to work hard to write the proof, but that's not my problem. But we don't have it, and we have to deliver a system, so we have unsafe extensions. The one common thread that everyone relates, Dan Nussbaum is adamant on this point, and I certainly saw it, is that when you dangle unsafe extensions to sort of in front of an unreformed C or C++ programmer, they think, ha, if I just had those, my code would run fast. That's what I need to use. And